record. Boom. All right, let's go. Question number one. So you had log base 3x of 8x squared minus 5x plus 14 equals 2. These questions are all going to be cut from the same strip of cloth, okay? It's going to be just immediate water cycle. So you're always going to be taking this to the power of 2, right? They're always going to be 2. Always, always. I mean, for now, for this. So 3x squared should have given you 9x squared, and then you set that equal to the argument, 8x squared minus 5x plus 14. And then quadratics 101, you want to move all your stuff to the left because you want to ensure that x squared does not go negative. So we're going to have 1x squared left, add the 5x, subtract the 14. And then that should be some pretty light work as far as factoring goes. So you should have x plus 7 times x minus 2, still equal to 0. We should be hanging on to that equals 0 at this point. Then our candidates for solutionism are x equals negative 7 and x equals 2. And you should have crossed out negative 7 because if you put it here where the red arrow is pointing, you get a negative base for a logarithm, which as we know is not allowed. If you put 2 in, it breaks no rules. You can put it in where the red arrow is. You can put it in where the yellow arrows are, and no rules get broken. So 2 should have gotten a box, and negative 7 should have gotten a cross. Remember that there are to be no naked answers. All answers need to either be crossed out or boxed or circled or something. Every answer, there should be an indication that you've checked it and that it either works or does not work. So don't leave any answers floating out there for me to interpret, okay? Any questions on number one? All right, so there's one solution to problem one, and it is x equals 2. For question number 2, we have log base x plus 5 of 2x squared plus 13x plus 25 equals, you guessed it, 2. And yet again, we're going to raise the base to the power of the logarithm. So x plus 5, when raised to the power of 2, you all should have gotten x squared plus 10x plus 25. As I've said repeatedly, if you struggle with that step, just write it out. If you're not going to square, multiply, double, like if you're not comfortable with that, it's okay. Just write it out as x plus 5 squared old school like this. And just do some old school algebra 1 multiplication on that sucker. No harm. All right, so we're going to set that square equal to 2x squared plus 13x plus 25. And at this point, we don't discuss logarithms for the next minute or so. We just go into quadratics mode. This time, we're moving all of our stuff to the right because we want, again, to ensure that the x squared term doesn't dip negative. So we're going to be left with a positive x squared over here, a positive 3x, and nothing, 0. So I did want to make sure that the practice quiz had one of these, just like the quiz will as well, to make sure that you're comfortable with factoring quadratics when there's a missing term. And where the missing term is really critical to how you approach it. A quadratic that's missing its back term, c, when c is 0, then how you approach it should not be like classic build your shells kind of factoring. Your thinking should have been, let's pull x out of both of these like this, leaving behind x plus 3. So you have the two factors now, the red one and the white one, and you just need to make them each equal 0. That's always the goal. It's why we factor. It is literally the reason why we teach you to factor, so that you can figure out where zeros occur. So the zeros are going to be from this one, x would have to equal 0. That's a potential solution. And then from this one, we have x equals negative 3. And just trying to address some concerns when I crafted these last night, I want to make sure we're clear. Like, I don't want anyone to have this misconceived idea that, like, oh, answers can't be 0 or answers can't be negative. Again, answers can be whatever they want to be, provided that they don't break any of the 5 rules. Remember, the base of your logarithm, the thing I have circled here in purple, what are his three rules? What can he not be? He can't be a negative, he can't equal 1, and he can't equal 0. And then we've got the argument of the log, the thing circled in red. What can't he be? He can't be negative or 0. So those are the 5 rules. I mean, that's really the only thing that could get you into trouble here, other than some shoddy basic skills along the way. But at the end, provided that you adhere to those 5 policies, then you just check your answers. And when you put 0 in, no rules get broken. So 0 can have a box. When you put -3 in, it's uncomfortable, but no rules get broken. If you put -3 in place of all of the x's, your base stays as a +2, and your argument winds up being positive something. I don't remember what it was, but it'll work out just fine. Okay, so they both get boxes in problem number 2. Have any questions about that? Okay. Question number 3 starts out as log base -2x minus 5 of x squared plus 27x plus 45 equals 2, I guess. And for the third straight time, 3 of 4, we're going to raise this to the power of 2. And again, if you're good with the square, multiply, double, do it. If you're not, write it out old school, okay? But what it winds up being is, I don't know why I put a parenthesis there. It's 4x squared plus 20x plus 25. And if you're going to make a mistake there, please don't just don't, let's finish the year without any like silly stuff, you know what I mean? Like little rinky dink stuff. So write it out if you need to. And then you got x squared plus 27x plus 45. Quadratic training kicks in, and we understand that all of this stuff is going to the west. So we're going to wind up with 3x squareds minus 7x's and minus 20. And then factoring kicks in. And the factoring is a little bit harder in a case like this, just because you've got a number on your x squared. But the shells, it's not bad. It's a 3x and a 1x. We, of course, understand that the signs are positive and negative. And you've done enough factoring, I think, by now to understand just the dynamic of how this works. There's like a feel to it. If you put a 4 here and a 5 here, you create the perfect blend because you made a 12 and a 5. And 12 and 5 have a difference of 7. It's exactly what we're going for. So at this point, now that we've created the dynamic we want, we just want to make sure we give the minus and the plus to the proper locations to make sure that when they add, they make a negative, not a positive. So we want to put the minus on the stronger. That would be the 12. And then put the plus on the weaker, the 5, to create the proper balance. So our candidates for solutionism are x equals -5/3 and x equals +4. So I can tell you the obvious one first is the easy one. I don't know, let's take the easy road first. If you put 4 right there, you get an immediate fail, an obvious fail, because -2 times 4 is -8, and -8 minus 5 is -13. And a logarithm cannot have a base of -13. So 4 can have an immediate slash. And this other one, I do believe that a lot of you will rely on your calculators a lot more heavily than others. And that's okay in a case like this. Testing fractions is a pain. So we're going to take -5/3 and we're going to put it where the red arrow is. And if it passes this test, that's bad news, because that means then that we have to go further and test again. The best thing that could happen here is maybe it'll just fail, and then we can not worry about the next test. Love it when that happens. So the mathematics, I'm going to take this little purple oval circled thing, and I'm going to write it out. So we can see the basic skills here. So it's -2 times -5/3 minus 5. That's the test number right there. And then again, it's for some of us something that we do in our heads. Some of us, we are not comfortable with it. What happens here in the part that I'm underlining in red is you get a positive 10/3, which is roughly 3 and change, right? It's 3 1/3. But what we do understand is regardless of how exact we are, if you take 3 and something and take away 5, there's no escaping the fact that that's going to be a negative number, right? So we don't even have to know, like, we don't have to calculate like down to the whatever exactly what it is. Just knowing that it's negative is like uh, mission accomplished. So this one gets across. And we would have to say on this, crossing them both out is not in and of itself the answer. We do have to explicitly state then that there is no solution. Got it? Sometimes, as you've seen, one of them works. Sometimes they both work. Sometimes neither of them works. That was my mission when I created this, was to say, let's get comfortable with the fact that, because I know in that Delta math assignment, they all just kept working. I was like, I didn't like that at all. So since I had control over this one, I decided to make sure that you're on your check-in game. So we head into number 4, not knowing what we're up against. Is this going to be a they both work situation, a one works, nobody works? So I tried to kind of set you up for that state of wondering what's to come. So here we have log with a base of x minus 4 of 2x squared minus 16x plus 28. And I'm only copying these down not to waste your time, but just in case anyone watching the video, then if they didn't have it, they could copy along. So that's why. So for the 4th straight time, we're going to raise this to the power of 2. And that square multiplied double is going to come out to x squared minus 8x plus 16. And we're going to set it equal to the argument of the log, like such. And then it's, 4th verse, same as the 1st and the 2nd and the 3rd. You're going to just go into your quadratics training, say, I'm moving all of you guys to the east. So that's going to give me a positive 1x squared, a minus 8x when I add 8x to both sides. And when I subtract 16, I get a positive 12. And I can tell you on the quiz, if you get to the end kind of like this end, and it doesn't factor, you did something wrong. Okay. I'm not going to like toy with you and suddenly throw a quadratic formula at you. So factorability is going to be a good kind of like milepost, sort of like a guide along the way to say, how am I doing? Not a guarantee, but if it doesn't work, that's a guarantee that something's gone wrong. So that's easy, super light work factoring x minus 2, x minus 6. Our solution candidates are 2 and 6. Who fails right away? 2, immediate. And again, we haven't even had to check any arguments yet because the fails keep happening in the base. If you put 2 right there, 2 minus 4 is obviously -2, and that's a no-go. So 2 can have a slash. You, sir, are the proud owner of a slash. And then 6 does pass the first test because 6 minus 4 is 2. So we're on to the second test. And if you put 6 right here, you get 6 squared is 36. 2 times 36 is 72. Minus, and then 16 times 6 is 96. And 72 minus 6, 72 minus 96 is -24. And -24 plus 28 is +4. Passes the test, so he can have a box. So that's what you can expect on the quiz. 4 questions, just like this. A nice sampling of they both work, nobody works, one works. Who knows? Do you have any questions at all on how to do that? No questions? All right. Well, the last 7 minutes are yours. Do with them as you see fit.